Hi, I'm Sean Bradley. I'm a materials scientist with Formlabs. I'm super excited to be introducing this new material for Formlabs. It's a Alumina 4N. Joining me is Jeff. Jeff, if you want to introduce yourself.
Sure. I'm Jeff. I'm also a material scientist here at Formlabs, and I'm super excited to be finally sharing some public information about this resin. We've had this resin under development for almost 3 years now, and it's our first technical ceramic. So I'm sure a lot of you guys know that we do have ceramic V1 out on the market, but that is a silica-based material. So this is our first technical grade ceramic moving into the alumina. So before we get into the meat of this presentation, which will be focused on the printing of the alumina material, Sean, can you tell us why you'd want to use technical ceramic to begin with?
Yeah, sure. So technical ceramics are really the superheroes of materials. They function in almost any of the environments where other materials fail. So for example, here you can see we're firing a oxyacetylene torch at the ceramic part. That flame is about 2000 degrees Celsius, and you can see that the part is holding up just fine. So these kinds of high temperature environments are one of the big areas that ceramics excel. They're also very, very good at chemical resistance. There's almost nothing that can dissolve, particularly alumina. There's all kinds of different abrasion properties, all of these different things that make it such that ceramics are really used where a metal or a polymer or anything else would actually fail. With that in mind, Jeff, do you want to talk a little bit about why you would print with it?
Yeah, of course. So I'm sure anyone that's familiar with working with ceramics in general is very familiar with the cost and difficulty associated with working with these materials. Ceramics are extremely hard, so they're not easy to machine, they're not easy to form. You're looking at extremely expensive tooling equipment. So the huge benefit to being able to 3D print some of these pieces is the fact that you essentially get shape for free when you're talking about 3D printing. You're not going to have to machine the parts. You're not going to have to do any special fancy processing after it. It's just the part is printed, and once you fired and sintered it, then you have your end part. This also allows you to really open up the design space. You can make parts that were previously unable to make using traditional methods. So that, combined with the power of being able to make essentially any shape you want, gives you the ability to cut down on costs, cut down on lead times on parts, and really push ceramics forward.
That's really cool. Uh, why would you use Formlabs in specific, though? I know there's a couple of other companies that are doing ceramics and have been for a couple of years.
Yeah, that's a great question. So anyone familiar with the ceramic 3D printer space knows that there's a few competitors out there that have been printing or 3D printing ceramics for quite some time now. So the main reason you'd want to consider us as the way to 3D print ceramics is cost. When you're looking at our other competitors, you're looking at machines that are far, far more expensive than what we have here. This material was designed from the very beginning to be printable on our Form 3 ecosystem. And you can just go to our site and see that the Form 3 is only $2,500. So with a small capital investment, you can get going and start printing this material right away. So that's the main advantage to using Formlabs ecosystem to 3D print the ceramics. The second one is that we are in a very strong position to scale because our technology is so cheap that once you've finished the prototyping and you have created a part, if you need to scale that part up and start to mass produce it, it's extremely easy to buy a fleet of Form 3s. And we even have custom software called Fleet Control that allows you to distribute jobs over multiple printers and really keep a whole print farm running to increase production. And then the last reason you'd want to consider Formlabs is actually our build volume. Many of our competitors have much smaller build volumes since ceramics are so difficult to 3D print. They typically focus on smaller build volumes to make smaller parts. On the Form 3, you do get the full build volume that we're known for, and you can really leverage the additional size of those parts. So whether you're printing one small part and doing many of them along the build platform, or you're trying to print one larger part, all of it should work.
Okay. Are all of these parts here printed on the Form 3?
Yeah, so all the parts you see here are some of our demo parts that were printed on the Form 3 and fired as printed with no additional post-processing or machining.
That's pretty awesome.
Yeah. So Sean, I have a question for you. Is a 3D printed ceramic as good as a material or a ceramic made using traditional methods?
Yeah, so that is a good question. So here's some of the properties related towards the ceramic that we're producing. In general, it is a 99.99% pure alumina. So any of the properties of that material, you can generally look up online and find it, and it will be a very, very similar result to what we have coming out of the Formlabs printer. We're
That's awesome.
Yeah, it is. It's really cool. At the end of the day, after firing, we're hitting 98.6% density out of the 3.986 grams per cubic centimeter. So it is a fairly solid alumina part. It's got absolutely nothing that isn't alumina at that point. So you can treat it like a regular alumina after that. The only real or the biggest real difference is the flex strength. So you do end up going down a little bit. The XY strength is still a pretty impressive 400 megapascals. The Z strength drops by about 20% to about 320 megapascals.
So why would the Z strength be so much lower than the XY strength?
Yeah, so largely that comes down to basically the waviness as you're printing in a layer-wise direction will cause these little crack initiators that can weaken your part. It is still pretty strong, but you're looking at when it's in the XY plane, you've got a RA of about half a micron or less. And in the Z plane, you might be looking at 1 micron to 3 microns, depending. So that's
Okay,
really
so the added roughness along the Z surface just increases the probability of having a defect along that surface.
Yeah, the actual bulk of the material is overall a lot more isotropic. You don't see, like you would in some other processes, you don't see that kind of separation of particles that goes preferentially to layer surfaces or anything like that.
Okay, and for a user, what does this mean? Does this mean that they need to orient their parts in a specific way to get the best properties out?
Yeah, it's generally a good idea to do that. The other side of that being that also we would recommend orient it in such a way that it's as much of self-supporting as possible. Supports, because you're going to have to remove them, will act as potential crack initiators, so you can substantially decrease your strength there. But once they're removed, you can also sand and polish them off pretty easily in green state, which gives you an ability to make it much smoother and much stronger overall. We've seen a fairly substantial increase in strength when it's been processed like that.
Yeah, that's great.
We actually have this video here of it breaking, and you can see this bar broke. There's no layer line style breaks. It broke cleanly through the bulk. So you're not seeing any kind of printer related processes. It's breaking more or less like I would expect out of a conventionally cast alumina bar in a similar 4-point bend test.
Yeah, you can see how it shatters and how there's not like one location of failure along the bar.
Yeah, I also can call to, you can see that it doesn't deflect at all. Once it breaks, it breaks. That's just how ceramics work. They go up to a load, and at a certain point, it's just done. So all of these properties are great. Do you want to talk a little bit about how we process it and how we get to there?
Yeah, that's a great question. So for anyone that's familiar with the 3D printing process, there's not that much different about 3D printing this alumina resin. It's compatible with our Form 3. We have all the settings predefined, and you just need to download our free software preform, load up your part as CADed, and then off you go with the printing step. Once you're done with the printing step, all you need to do is take the part off, and since it's now covered in the uncured resin, you just need to wash that part. For the ceramic, we do have a custom ceramic wash solution that we will be selling in addition to the resin itself. You can take that custom wash solution and then wash those parts. It's compatible with our entire Form 3 ecosystem. So you can put that solvent directly into a form wash and just wash your parts as you normally would. Once you have finished.
Is that solvent at all dangerous or flammable or anything? Do we have to worry about
Yeah, that's a good question. The solvent is not at all flammable. This is a completely safe solvent. It should be pretty easy to integrate in your lab and dispose of. Yeah, so there's no concerns when trying to use the solvents. It's pretty benign, but does a great job of washing the uncured ceramic off of the parts. So using the foam wash, it should make it pretty safe and hands-off to clean your parts. Once your parts are fully washed, you don't want to evaporate the solvent too quickly because that would cause stresses along your part. So you typically want to slowly dry your part to keep the uniformity and prevent warping. Once your part is dry, you're ready to debind, and that's the act of fully burning out the polymer component so that you're left with your alumina powder left over. We call that a brown part. And then once you finish your brown part, you move over to a sintering oven where you would bring it up to standard alumina sintering temperatures, close to 1510 C, and then fully densify your part into the final body.
Cool. So that process, once you get past the printing and get into the debinding, it really becomes the same as any other traditional ceramic, almost, of just that standard sintering, right?
Yeah. So your debinding step is highly dependent on how much polymer component you have. So depending on your ceramic forming method will depend on how much you have. One important thing to note is we do typically recommend doing the debinding step and the sintering step in two separate furnaces so that you don't gunk up your elements with all the organic compound being burned off. So we recommend doing one debinding step in an oven up to about 500 C, and then we recommend bringing that temperature up to 1000 C to increase the brown strength of your part. That'll just give the part a bit of extra strength so that you can take it out of your debinding oven, move it to your sintering oven without risk of breaking your parts.
Okay. All right. Thank you. I think the only other comments that I can really make is that we have a webinar that's upcoming later this month. There should be a link for that down below. And anything we talked about and a lot more, there's a bunch of articles online for this that should be there to support you, hopefully talk you through it. And we look forward to seeing what people are doing with these. This is got a lot of really cool applications, and it's one of the most extreme materials that Formlabs has ever released. Thank you.
Yeah, we're super excited. Thank you.